welcome all of you. We will deal now with the next part of material balance. Process. To understand the process, first of all, we will deal with again system. What is system? System is the macroscopic portion of the universe which is under investigation. So there are some terminologies we have to consider for a system. The system in which certain mass may be there or certain fixed mass may be there. Okay, so which is under investigation. So we can say that the system is at one state, at a particular state. Okay, so this state of a system may be changed, or the system can move from one state to another state. So what exactly is the state? It is the condition of the system. Okay, it is the condition of the system. Suppose temperature, pressure and volume, these are the variables. Okay, so when the system is at this state where the temperature, pressure, volume of that system is supposed to be having some value. So when this system moves from one state to another state, then these variables changes. Okay, so the temperature which was initially may get changed when the system moves from that state to another state. So this is possible when there occurs a certain process. Okay, so system can undergo a state change or a change in state, or a system moves from one state to another state. Where it is possible when there occurs a process. So what exactly is a process? Process is a series of operation or one or series of operation in which physical and chemical treatment are carried out. Okay, and a desired product at the end is expected. So whatever the desired product or a desired end is expected, then we have to perform a series of operation which may be physical or a chemical treatment, so that a system can be brought from one state to another state. Okay, this is the objective. This is exactly the objective that we are expecting, that a system should change. So to system should change its state, it means that it must have to undergo certain process. It must have to undergo certain series of operations. This series of operation, after performing that, the system changes from one state to another state. Okay, so this is through the process. So the process is a series of operation. Okay, process is a series of operation. It may be one operation, or it may be a series of operation. So what kind of operation? It may be physical and chemical treatment that may be given to the chemical that are involved in a system, and at the end what we get is the desired product. You can take the example. For example, a distillation unit, then drying, absorption, chemical manufacture, that is in a reactor. So all these are the examples of what they involves certain process. Okay, so system can be a distillation unit. Okay, so once the mass enters into the distillation unit, then it may have a fixed variables. Okay, so we can say that this system is at one state. When the temperature, when the heat is provided, then what happens? The system would try to move from this state to another state, and when it moves from for initial state to final state, what happened? The variable changes, and when the variable changes, what happens? There will be a evaporation. There will be a evaporation takes place. That means the mixture would be separated on the basis of their boiling point. So the constituent which is having low boiling point vaporizes, and while the constituent which is having high boiling point remains in the system, and thereby what we can separate the two constituents from a mixture. So this is possible. This is possible only when we perform certain series of operation on a system. So we can bring that, we can make that system to move from one state to another process, and this is possible only when we perform some series of operation. Okay, so when that series of operation is nothing but a process that make the system to move from one state to another state. So here you can see that initially the material enters into the system, the process takes place, and finally the material leaves the system after the process is finished. That means process may be anything. Okay, process may be anything. It may be due to mass transfer. It may be due to what we say variable changes. Okay, so we can say that initially when the material enters, it undergoes certain process, and finally it gives out certain product. Okay, certain product. This process, on the basis of how material crosses the system boundary, are classified as batch process, continuous process, and semi-batch process. Okay, process on the basis of how a material crosses the system boundary. Okay, how a material crosses the system boundary, based on that, or based on that, classification is done as batch process, continuous process, and semi-batch process. We will see here one by one in detail exactly what is the batch process, continuous process, and semi-batch process. So batch process is that process in which the material or the feed material is introduced in the system. Okay, feed material is introduced in the system. So here the system may be, suppose, any reactor, any mixer, any filler, any distillation chamber, evaporator. So many examples you can take of the system in which initially the feed material is introduced into it. Okay, then this feed material is remain in the system for a certain period of time. What we call this as a residence time or a retention period. So during that time there may occur certain physical and chemical changes in the chemical. Okay, so there occur certain physical and chemical changes in the chemicals. So during the residence time, or whatever the time that material remains in the system, there occur physical and chemical changes in the material. So certain changes that are expecting out of this process, once it has been achieved, what we do, we take out all the product all at once time, all at once. Okay, we take out all the product, or we remove all the product all at once. Okay, all at once. So here we can say that in a batch process, once the feed material is introduced in the system, again if you want to introduce the material into the batch process, it is not possible. That means once the feed material is introduced, later on no mass crosses the system boundary during this time. That means unless and until the process is over, you cannot make the mass further to enter into the system, and therefore this is what we call this as a batch process. Okay, this is what we call this as a batch process, and this batch process actually correlate or fall into the category of closed system. Actually, we have seen in the closed system that in a closed system, mass cannot be allowed to enter into the system, while the surface or the system boundary is conducting, and therefore the energy can be exchanged with the surrounding in a closed system. Similarly, in a batch process also, mass, once it has been entered, later on it cannot be allowed to cross the system boundary. Okay, but however, or we can say that the energy can be entered into the system and energy can be taken out of the system. So we can say that in a batch process, the feed material, once it is entered, then it resides or it remains in the system until all of the physical or chemical changes occur. So once the desired or the expected product is obtained, then all of the product is taken all at a time, and in this process there is a restriction that no mass can cross into the boundary, no mass can cross the system boundary during the when it is undergoing the process. Okay, moreover, you can say that batch process actually fall into the category of closed system. Okay, uh, and whenever we want to perform some material balance calculation, then we have to take into consideration two facts. One fact is that the material balance calculation is done on a single batch or a one batch. Moreover, there should be no chemical reaction involved. That means the chemicals that are entering into the process or entering into the system which undergo certain process, okay, which undergoes certain process. So these chemical are not at all to be reacting in the during the process. Then you can use this equation in order to calculate the material balance, that is the material that is entering into the system and the material that is leaving out of the system. It should always be equal to input is equal to output. So this must satisfy, okay, this must satisfy for batch process, as this process, if it do not involve any kind of chemical reaction, the batch material balance calculation can be done on one batch, or the basis of calculation is one batch, and the equation is input is equal to output. So here you can see initially though no material, okay, no material enters into the system, and here you can see the material is now entered into the system, and further no material then crosses the boundary. It means that the moment all of the material is taken in the system, the lid is closed. Then if you want if you want further to add a material into the system, you cannot enter, or you cannot allow that material, or the material cannot be allowed to enter into the system. So such process we call this as a batch process. Okay, so to review this one again, we can say that batch process is that process in which the material or the feed material is placed into the system in the beginning of the process. Then this material remains in a system which undergoes some physical and chemical changes, and finally when the expected product is appeared, then all of the material or all of the feed all of the product is taken all at a time. There is a restriction. Once the feed material is entered into the system, next if you want to allow further material to add into the system, it is not possible, as no mass crosses the system boundary, since this is a batch process and it is as good as closed system. Okay, so batch process actually fall into the category of closed system, and we know that in a closed system no matter enters into the system while the boundary is conducting, and therefore energy can be exchanged. So this similarly happens with the batch process also. Now the next process is the continuous process. So what exactly is a continuous process? It is equal to what we call the open system. As in the continuous process, the input as well as the output or we can say that there is a continuous input of a material into the system. Moreover, there is a continuous output of a system, output of a material from the system. That means input and output of a material are continuously transferred across the system boundary. That is, the input and output can be transferred across the system boundary. That is, feed enters into the system as well as the product continuously leaves the system. Moreover, the physical and chemical changes takes place. Okay, physical and chemical changes takes place during the flow of material through the system. Okay, through the system, physical and chemical changes takes place during the flow of a material through the system. Okay, through the system. And that is why we can say that here, whenever we want to perform the material balance calculation, then what we have to assume the basis of calculation is the time, that is as minutes, hours, day can be chosen as basis of calculation. Here this continuous process, okay, continuous process actually allow the material to enter into the system, simultaneously the product leaves the system. So during the flow of input into the system, chemical reactions or physical changes in the chemical takes place during the flow only, okay, during the flow only. And therefore we have to take into consideration the material balance calculation on the basis of time, okay. The basis is the time. This time could be taken as minutes, hours or day, okay. The next one is the semi-batch process, okay. So in a semi-batch process, there is either a input or a output. That is, there would be just a flow of chemical or flow of mass into the system, or the mass can leave the system. There is only one part we can say that there would be a just input or a output. Like what we say continuous process, there is no chance for a input as well as a output to enter into the system and leave the system. Here there is a restriction that either there is an input of a chemical or a substance into the system, or there is a output of a chemical from the system. Therefore we can say that this is a semi-batch process in which there is just a one way what we say input or a output. Fed batch process is one of the specific or a typical type of semi-batch process in which there is a possibility that only input is there, or there is a input of a chemical or a substance into the system, but there is no output, okay. There is no output. That means once the process is over, all of the product can be taken from the system, okay, taken from the system. That is, there is only a flow to enter into the system, but there is no chance for a product to leave the system unless and until the process is over, okay. Unless and until the process is over, or a system can be brought from one state to another state. When this happens, then and then only the product can be taken from the system, okay. Product can be taken from the system. So the best example in industries that we use is the semi-batch reactor, which is also called as stir type tank reactor, okay. Stir type tank reactor. It has a very good what we say characteristics. What that characteristics is that the reactants, okay, reactants, one reactant can be allowed to enter into this reactor. Then another reactant can be made to enter into the system continuously. So we can say that one of the reactant initially put into the reactor, so it enters as like what happens in the closed system. The another reactant is allowed to enter into the system continuously. So it will behave as like what we say continuous process, okay. Continuous process or continuous process, okay. It behaves like as continuous process. So we can say that semi-batch process actually operate in between batch process and continuous process, okay. Batch process and continuous process. So semi-batch process is an intermediate process as it could relate to batch process as well as to the continuous process, okay. So why this semi-batch process then is very essential in industries, okay. You know that most of the chemical reactions takes place exothermic, okay. Most of the chemical reactions are exothermic. There is lot of heat may be involved, or lot of heat may be evolved during the process. So if lot of heat is evolved, then it would be necessary for us to control that heat. Otherwise the reaction would just what we say char the product, okay. The heat involved may char the product, or heat involved may burn the product, and sometimes there could be chances of blasting. And to avoid all this, we use what we say stir type reactor, okay. Stir type reactor, in which what we do, one of the reactant we fix into the or add into the system or in the process, and another reactant is continuously fed into the system or in the system. So the process takes place. So gradually this reactant product get formed. So whatever the heat involved, that heat would be less in quantity, and that involved heat would be controlled easily. Okay, and that is why we can say that this semi-batch reactor or a stir type reactor are very essential whenever we want to perform chemical reactions which involve evolution of lot of heat. Okay, which involves the evolution of lot of heat. Okay, so here you can take the example of semi-batch reactor. Here one of the reactant is already fed into the system, and it would behave here partially. It would behave partially as like a closed system, and another reactant, look at here, B, is fed into the system continuously. So this reactant would behave as if it is flowing into the system continuously. So this stir type reactor here would behave as partly what do we say, a semi-batch process, and partly as like a continuous process. Okay, this to achieve only a good yield of a product, since most of the reactions or the reactions which actually involve a lot of heat.